Okay, we're here in the fourth video already, and we're looking at some examples. So if we have something like 3a cubed b times 2ab squared, what do we do with it in order to simplify it? We multiply all the parts together as we can. We could write this out the long way. I don't recommend doing it all the time, but it's good to do sometimes for practice. So 3a cubed b is 3 times a times a times a times b. And 2ab squared is 2ab, b. And then we can just count up how many a's we've got. We've got 1, 2, 3, 4. And how many b's we got? We've got 1, 2, 3. So we could say that we've got 4 a's and 3 b's. And what's left over to do is just these numbers, 3 times 2, which is 6. Or we could count them up without expanding first. We could say there's 3 times 2, that's our 6. We've got 3 a's and another one, that's 4. And we've got 1 b and 2 more, that's 3. Do this way for practice a few times until you're sure you know what you're doing. But afterwards, please feel free to, I'm going to write times like this, please feel free to just go the short way. So here we have a messier one. We've got 7x to the 0 y cubed z over x squared y z squared times 3x cubed. That's a big jump, hey? Z cubed over xy to the 0. The first thing I'm going to look for in one like this is any exponents that are to the 0. Because anything to the power of 0, anything to the power of 0 is equal to 1. So that's just a 1. And that's just a 1. And now my life's getting a lot easier. So 7 times 1 times 3 on the top. 7 times 1 is 7, times 3 is 21. On the top, I'm gonna work through this one, do the tops, and then do the bottom. Y cubed, and there's no other y's, so there's a y cubed in there. There's 1z and 3 more, so that's 4 z's. And there's 3 x's, so there's x cubed. I'm doing them in alphabetical order, x, y, z. Not because you have to, just because you should. It's polite. And on the bottom, I've got x squared, y, z squared. Nothing over here because that was all to the power of 0, which was a gift. Now, I've got x cubed on the top and x squared on the bottom. I know that if I have something like this, that's the same as subtracting those two exponents. That's from our exponent laws. So we'll do that. So we have x to the 3 minus 2. 3 minus 2. We've got y to the 3 minus, there's no number, so it's a 1. Z to the 4 minus 2. So that's 21x. 3 minus 2 is just 1x. Y to the 3 minus 1 is y squared. And z to the 4 minus 2 is another z squared. So that is a simplified version of the mess we had before. We could have dealt with this entire fraction first and then multiplied by this. That's okay. You'll get the same result if you try. Don't believe me, just watch. So if we have 7 times y cubed times z over x squared y z squared. Now we have 2 x's on the bottom, no x's on the top, 3 on the bottom, so 3 on the top, 1 on the bottom. That's 2 left on the top, so 3 minus 1. And with the z, we have 1 on the bottom, and so 1 on the top and 2 on the bottom. So we've got 1 z left. So of these 3 y's, when I get rid of this one, kind of knock it out with 1 pair there, z to the 1 and z squared. If I cancel, I'm left with still 1z on the bottom. If I have to then multiply it by this, I can write it over 1, and I might as well. Then I have now 3 x's on the top and 2 on the bottom. If I cancel 2 of those with 2 of those, I'm left with just 1 x over here. I've got 3 z's on the top, and I've got 1 z on the bottom. If I cancel 1 of these with 2 of those, that becomes, sorry, 1 of those with 1 of those, that becomes z squared. Just to be clear, this was z cubed. 3 minus 1 is 2. I think I misspoke there. And I've got a y squared on the top as well. So now I've got a 7, I've got a y squared, I've got a z squared, and I've got an x. I've also got a 3. Oops, I forgot to go times 3. 7 times 3, 21. That's a little bit better. It's the same result we had last time. I did this one a little bit rushed, but I want to make sure these videos are short and you can always rewind. Here we've got negative 3n squared m over 2p divided by 6m over negative 4np. The very first thing I'm going to do is deal with that. When you divide by a fraction, that's the same as multiplying by the reciprocal. So we've got negative 4np on the top now and 6m on the bottom now. That'll be a little bit nicer, I think. Those guys over there. So we can go through either bracket, clear this one up, and then this one up, or we can go top and top, bottom and bottom. I like to go top and bottom, so let's do that. So on the top, we've got a negative 3. We've got 2 n's there and 1 over there, so that's 3 n's. We've got 1 m, and we've got 1 p. On the bottom, we've got a 2, a 6, put the numbers together, an m, and a p. If we're looking to cancel out pairs, m by m, p by p, there's 3 n's that don't have anything to cancel with. And for negative 3 over 2 times 6, 2 times 6 is 12. So negative 3 over 12 is, well, negative 3 over 12 reduces to negative 1 over 4. And we still have n cubed, which is the only other thing that didn't cancel out. We'll do a few more here. 5 squared times 5 to the 8 over 5 times 5 to the 4th times negative 3xyz to the 0. Right away, my eye is drawn to that 0 exponent because it's for free, right? It means that all of this I don't care about. It all equals 1 times 1. Anything times 1 is itself, forget about it. Now I've got 2 5s and 8. So 2 plus 8, which is 10. And on the bottom, I've got 1 5 and another 4. And 5 to the 10 over 5 to the 5th power is, well, 5 to the 10 minus 5, which is 5 to the 5th power. And 5 to the power of 5 is got to be 3,125. And, yep, that's much nicer than what we started with. A couple more here. A couple more. Maybe I'll pause this and break it into a few videos. We'll do a couple more and then we'll do next video. So here we have 1/8 to the 7th power times 1/8 to the 3rd power. The base here is the same. The base is 1/8 in each case. So this is the same as 1/8 to the 7 plus 3, or 1/8 to the 10th power. That's the same, in case you want to write it out this way, as 1 to the 10th over 8 to the 10th. 8 to the power of 10 is going to be something huge. I don't want to write that out as a number. But 1 to the 10 is just 1, right? 1 to the power of anything is just 1. So 1 over 8 to the 10th power, or another way I could write this is 8 to the negative 10th power. This, and this are all acceptable endpoints for this type of problem. Do one more and then I'll switch over to next video. No, I won't. I'll skip over now. It's almost 10 minutes. Get real professional video quality out of me.